Alright, we're gonna do 2 cars, same point, because I want to save the snowball one for last. Alright. 2 cars. Oh, yeah, number 15 on the 3.9 textbook. I'll go get my textbook actually, so it's easy to read. Alright. 2 cars start moving from the same point. One travels south at 60 miles per hour, and the other travels west at 25 miles per hour. At what rate is the distance between the 2 cars increasing 2 hours later? So first, let's start with the point from which the cars start moving. Actually, let's write the number this is because out of habit. Okay, now and that's number 15 because the question it's question 15. Okay, there we go. Okay, first let's start. Just put the point that they start at. So they start right here at this point, and the 2 cars are somehow simultaneously on this point. I'm pretty sure that means that they're either on top of each other or just someone's car is getting damaged. I don't know, but that's okay. They're at that point. So anyway, one travels south at 60 miles per hour. So let's draw a line south, or down. Okay, that's the hang on. All right, there's my line. They went south. So now, one travels west at 25 miles per hour. So west is gonna be this way. All right, hang on. Alright, so this is the west one, this is the south one. So let's let S represent the distance the car that was traveling south has gone, and let's let W represent the distance the car that was traveling west has gone. Now what does it want us to do? Well, it says at what rate is the distance between the 2 cars. So the distance between the 2 cars would be from here to here, because this is where this car is, this is where this car is. So we're going to draw a line here, a hypotenuse. It looks like, well, is this another right triangle? I love right triangles. And we do them constantly. It's better than a shape that I don't know the formula for, so it's okay. I'm going to fix this. I kind of messed it up, but that's okay. You can still see that it's a triangle. Okay, so this line represents the distance between the car that's going west and the car that's going south. And y will represent this distance. So now, let's do one travels south at 60 miles per hour. So that means the one traveling south, the rate at which it's traveling south is ds over dt. And that's going to equal 60 miles per hour. And then the one that's traveling west, dw over dt, the rate at which is the rate at which it's traveling west. Let's see what it is. 25 miles per hour. So 25 miles per hour. Okay, so now, what are we trying to solve for? I think I already said that, but at what rate is the distance between the 2 cars increasing 2 hours later? So, the rate at which this distance is increasing. So the rate at which y is increasing then. So that's going to be dy over dt, and we're finding that. So find dy over dt after 2 hours, because it said 2 hours in here somewhere. Yeah, 2 hours later. All right. So, how are we going to do this? Well, we have the same thing, Pythagorean theorem. We've been doing this a lot now. So y squared equals w squared plus s squared. And so now, we just find the derivative like we normally do. So 2y times dt. Oh, Jesus. Okay. 2y times dy over dt, because we got the 2y, and then we gotta multiply it by dy over dt so we can have it relative to time. And then we have 2w times dw over dt plus 2s times dw. Oh my god, alright, hang on. 2s times ds over dt. Okay, so now let's get rid of the 2's. This because each term has a 2, so we can get rid of the 2's. The next thing we have to do is we have to plug in the values that we have for all the values that we have that aren't dy over dt. So we don't have y, w, or s. We have to solve for that. So let's see what it gives us. Well, it tells us that at what rate is the distance between the cars increasing 2 hours later. So they've been going for 2 hours, and it gives us how fast they've been traveling in miles per hour. So with that, we know that W and S are going to equal their respective rates. So W's rate is going to be 25 times the number of hours, and 60, and then S is going to be 60 times the number of hours, which is going to be, and number of hours is 2 hours, so that's going to be 25 times 2 equals 50. And then this is going to be 60 times 2 equals 120. So now we know that W equals 50 and S equals 120. Now we have to find Y. Well, we know Y squared equals W squared plus S squared, so let's do that. Y squared equals W squared, which is 50 squared, plus 120 squared, which is, because that's S squared. S is 120. So now we have Y equals the square root, and then I'm going to do 50 squared plus 120 squared on my calculator. So 50 squared plus 120 squared. Alright, so we have 16,900. So Y is the square root of 16,900. So now that we have that, we can do this. So 16,900 times dy over dt equals W, which we know is 50, times dw over dt, which we know is 25. Oh, I forgot to close this parenthesis. Plus, let's see, 50 times 25 plus S times ds over dt. So we know S is 120, and ds over dt is 60, so 120 times 60. And now we just divide by this on each side, so square root of 16,900. So we have dy over dt equals 50 times 25. Okay. 50 times 25. And then we're going to add that to 120 times 60. So plus 120 times 60. And then that's going to be 8,450. So this whole thing is that. Okay, so dy over dt equals 8,450 all over the square root of 16,900. All right, and so we just divide this by the square root of 16,900. Yep, that's 12. There we go. All right, and that's 65. So dy over dt, or the rate at which y is increasing when they've been traveling for 2 hours, is 65 miles per hour. And that'll be your answer. And I checked, and let's see, where is it? 15. Right there. Yeah, so 65 is the answer to 15. Which you probably didn't need confirmation of, because this is just too perfect of a number. But you know. So that's that. That's the two cars same point problem. Let me know if you need any more help with this one or any of them. We are reaching the end. We have one more. We have the snowball one. The snowball one is actually not that bad. You just need to know this formula for it. But other than that, it's not that bad. I just wanted to do it last because it has a special place in my heart. Okay. Yeah, that's that. That's how you do that. Let me know if you need help with anything else. These are all on the test, remember? So that's why I'm making this. Okay, goodbye.